Cell phones away, please. Let's see how we do with this. All right, I am in Unit 2. If you have your notebooks, open them on up. I don't know what page it is because we don't have page numbers. So it's Chapter 2, Section 2.1. Okay, multiplication counting principle. I think you've all have done that. You just basically, you get a total of possibilities for each event. So if there's, let's put it away. If there's 20 different, if you had 20 different shirts and 10 different shorts, and let's say they all happen to coordinate, so then you would have 200 outfits, basically multiply the two. A lot of times you'll see these put together where it's like you're going to go on vacation, you're going to bring 4 shirts, 3 shorts, and 2 hats. How many different outfits could you wear? So you just have to multiply all of the different 4 shirts times the 3 shorts. 4 shirts times the 3 shorts, shorts, and then 2 times 2 hats. So people would see, oh, you wore that shirt yesterday. So that's basically the general multiplication counting principle. So example 1, you have 5 pairs of shoes in your closet, 8 shirts, 5 pairs of pants. How many different outfits do you have? So 5 times 8 times 5, so you have 200 outfits there. You want to order pizza. There are 6 different meat choices, 3 sauces, 5 cheeses, 7 veggies. How many different pizzas can be made from each of these? So you're going to go 6 times 3 times 5 times 7, so you get 630 different pizzas you can order. Colorado license plates consist of 3 letters followed by 3 digits. How many different plates can be made? Well, there's 26 letters in the alphabet, so 26 times 26 times 26. And then how many different digits can you have if you don't repeat the digits? So there's 10 digits originally because 0 through 9 is 10 digits. So then it's going to be 26 times 26 times 26 times 10 times 9 times 8, which means that's 12,654,720 items. Growing up as a kid, when I moved to Arizona in 1974, my telephone number to my house was 839-1202. But if you lived in Tempe, Arizona, you could just dial 1202, and you could reach anybody in Tempe. And if you were outside of Tempe, you dial 839 and then 1202. And if you were on the west side of Central Avenue in Phoenix, you would have to dial 1-839-1202. And then if you were outside of the Phoenix metropolitan area, such as in Prescott or Flagstaff, you had to dial 1-602-839-1202, and so on and so forth. So the combination of telephone numbers in Tempe, Arizona was basically there was about 9,000 residents in Tempe, Arizona. So that's why you could get away with dialing 1202 to get a hold of your friend. So my friend Matt across the street, you could dial 0460 and his house would ring. So that takes you back a while ago, a lot of the phones back then. Thank you very much. Let's see, who's that for? Oh, he's not here right now. I don't know where he's at. If you see him, let him know when that class started.
Call him Cupcake.
I was supposed to call you Cupcake. I'm sorry. So right. Thanks, Cupcake. He was right there. Call me Cupcake. He's going to report you. All right. Factorial. When order does matter. So factorial is, you have an exclamation point. So 5 factorial would mean 5 times 4 times 3 times 2 times 1. So you multiply that together, you get 20 times 3 is 60 times 2 is 120 times 1 is 120. So 5 factorial is 5, 4, 3, 2, 1. Yeah, you got 5. Or 10 factorial. Factorial grows pretty quickly because you're just multiplying a whole sequence of the numbers all together. And so how many different ways can you burn 11 of your favorite songs on a disc? So we're not worried about the order. You you just want to know how many different ways could 11 songs be burned onto a CD from iTunes. It would be 11 factorial, so 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. And you get that. And how many ways could you arrange 8 books on a shelf? And a lot of times in statistics and arranging things, we will use arrange books on a shelf, music on a CD, things like that. If we're not too worried about, I want this song here, this song here, this song here, or this book first, second, or third, you can arrange 8 books on a shelf by going 8, 7, 6, 5, 4, 3, 2, 1, multiplied together, and that would be going with that. So through the statistics books, page 79, 80, let's see what these said. Okay, so the factorial of a number is indicated by writing an exclamation point after it. If n is a natural number and n is greater than 0, the value of n factorial is defined by the product of all the natural numbers less than or equal to n. So if n equals 0, then by default 0 factorial is equal to 1. Factorial is not defined for negative numbers. As n increases, the value of n goes up rapidly. When n reaches significant values, the factorial skyrockets. There's a formula for approximating when n is large, and they have it as n factorial. So if you have an extremely large number, you have n factorial, or n to the n is equal to e over n. And that's the same thing as what n factorial, and this is an approximation. So your calculator, if you went like 1,000 factorial, it's probably going to give you an error. Or if you go like 10,000 factorial, there's just a certain number that your calculator will no longer be able to do the iterations for, because it goes up to the 99th, 10 to the 99th power, which is 99 zeros, and if you go beyond that, then that becomes a problem. Best place to find factorial on your calculator, if you forget to find or where to find it, it's under 2 different locations. It's both to me is the same thing. The first one, it's under catalog, which is the second of the 0 key. So if you go second catalog, and then you go up, because it goes all the way through all the alphabetical stuff, and if you go up, I can see it. It's right at the end. So if you went to the end of the alphabet, there's Z trig on most, and then the next one is factorial, and then not, and then radians. So your factorial is at the end of the alphabet. If you go use the up arrow, you get there a lot quicker than if you down arrow it. The other place you could find factorial on your calculator, so that's just if you forgot this way, is under stat, which is right under the delete key, and it's under stat, or is it under bars? Yeah. Hang on, I gotta double check. Stat, calculate. I'll find it. There it is. Okay, so it's not under stat. It's under the math button. And then you go over to PRB. And it looks like it's the 4th one down on PRB. So math is over on the far left of your calculator. And then go use your arrows to go under PRB. You'll find the factorial button. Is that okay so far? Did you find the math button?
40,000 is too big to factorial.
Perfect. All right. So, factorial obviously can get pretty big pretty quickly. And then improbability is often necessary to choose small sets from large ones or to figure out a number of ways in which certain sets of outcomes can take place. Permutations and combinations are two of the most common ways done. Before we define these, however, we define factorial, which we did. So, what kind of locks do you have on your locker? What are they called? Yeah, those are actually permutation locks. Permutation, the order is important that you put the stuff in a combination lock. If your combination was 20, 30, 5, you could put those in any number if it truly was a combination lock. It's a permutation lock because the order is important. Fortunately, we screwed you guys up way back when we assigned you lockers, and the lock companies had no idea, the difference between combination and permutation. So combination order is not important, which goes against everything you think of because your combination lock order is important in order to get into your locker. So those lockers out there should be permutation lockers, not combination lockers. Not quite sure where we fell off on that. Okay, so permutations. It says, suppose Q and R are positive integers. Imagine a set of Q items taken R at a time in a specific order. The possible number of permutations for the situation is symbolized Q, P, R, can be calculated. So I'm going to go back with what is in your notes. So permutation, the order does matter, but we are not necessarily choosing all of them at the same time. How many ways can R items be arranged in order? So they're using this. NPR is equal to n factorial over n minus r factorial. And the way you can do this is if you see the word arrange, it goes with permutations. Okay, think of it this way. Arrange of permutations, AP. Okay, advanced placement. Range of permutations are going to go along with each other. So how many ways can you arrange 5 books from a stack of 8 on a shelf? So you have 5 books that you want to put on a shelf. But you have 8 different books that you want to do this for. And again, this is one of those where you're looking at it going, who cares? I get it. But as far as visually seeing something, let's say you had 8 classic novels that you want to display for whatever reason, but your shelf is not large enough to put all 8 up on the shelf. So we're going to pick 5 of them to put up and display on the shelf for all to see. So we're going to go 8PR. So 8P5, which is then going to be, let's follow this along. The N is first, so I have 8 factorial over n minus r, so 8 minus 5 factorial. So 8 factorial is 8 times 7 times 6 times 5 times 4, 3, 2 times 1, right? And then 8 minus 5 is 3, so 3 factorial is 3 times 2 times 1. And an easier way to sometimes go through these is start canceling out. The 1 cancels the 1, the 2 cancels the 2, the 3 cancels the 3. Now you just have 8 times 7 times 5 times 4, or 8, 7, 6, 5, and 4 multiplied together. And so this means that we have 6,720 different ways that we can arrange those 5 different books, or those 8 books, if we pick 5 of them at a time to arrange. In order to find the NPR key on the calculator, first thing you're going to do, if we're going to do this problem, 5, we're going to type in just the number 8 first. So if you have your calculator out, type in the number 8. Then you're going to hit math. Then you're going to go over to PRB. And you're going to find the NPR button. Does yours come up with parentheses right away? Okay. Hey, I don't think it'll matter. And then at the end of your NPR, then you put 5. And once you hit enter, you're going to find that this comes out to 6,720. So when you're going to use the NPR button, you need to type in the number first. I don't think any of the calculators hit the NPR and ask you for the first bound and then the last bound. I think you type in the first bound. So in our case, we'll type in the N, whatever that value is, and we'll figure this out. So a range goes with permutation. AP. AP go with each other. So you have to look sometimes at the language of how these are written. If they use a term like a range, that should point to the direction that you're going to use permutation. Okay? How many ways can you vote for a president, a vice president, and a treasurer from a class of 30 people? So, president, vice president, and treasurer, you have 30 people. Okay, yes, there are people that will say, hey, I'd like to be president. They'll step up to the position. There's people that won't. But if we were just going to say, okay, I'm going to pick 3 of you, and between the 3 of you, you have to figure out who's going to be president, vice president, treasurer. So a lot of times when you have, how many ways can you vote for president? When you have 3 different specific named positions. Or if I said, how many ways could first, second, and third place be won in a race? Or things like that. Where there's a laming to it, we're going to also go with permutation. So this is going to be 30p3. The reason it's 3 is because we have 3 identified positions. Okay, which is then going to be 30 factorial over 27 factorial. A lot of times when you plug that into your calculator, it might get an overload because it's too large of a number. How some books have gotten away with it is, you know that 30 factorial is 30 times 29 times 28 times 27 factorial, all over 27 factorial. If I did it that way, what 3 numbers am I having to multiply together to get the answer? 30, 29, 28, because the 27 factorial does what? Yeah, this would reduce with this. Okay, and that your calculator can handle really easily.
My calculator would have to do the
You got 30p3?
Yeah.
Okay. What'd you get?
24,360.
Okay. And again, it wouldn't be that big. I just wanted to show you the little trick that sometimes is there. That the calculator, if it goes to an overload, it just means there's too many. It goes out, beyond 99 places. So in a class of 30, about this size class, that's how many different ways I could arrange 3 people to take on president, vice president, and treasurer. Yeah. I could be a goofy math teacher and say, all right, I want you to sit in a different seat every day throughout the year, making sure that you don't sit next to, in the same seat next to the same people. Be kind of a lot. Okay. So permutation goes with a range. Now we're going to get to something called combination. Combination order doesn't matter. Okay, how many ways are there in a set of R items from N objects? So combination goes like this. It looks like NCR, which is the same thing as N factorial over R factorial times N minus R factorial, which right here, that's permutation. Right there is combination. Permutation, combination. So how many ways can you choose? Now, if I'm going to go with choose, the word choose versus arrange goes with permutation. Choose goes with combination. So the C goes with the C. So how many ways could you choose 6 books from a stack of 8 to read on your trip? Okay? The last one we talked about with books is how many ways could I arrange? You need to use the term arrange that meant permutation. If I use choose, that's going to mean we're going to do a combination. So if you have 8 books that you have to select from sitting on your bookshelf, and you're like, I'm going to take 6 of these on my vacation with me, how many different ways could you choose those? So this is going to go forth with 8 factorial over 6 factorial times 2 factorial. Where did the 2 come from? Yeah, well, it's 8 minus 6, right? So the n minus r. So the first bound versus the last bound. Okay? So how many ways could you choose this many books to read? And this should come out to 28 books. Combinations under the same spot on your calculator. So again, you're going to hit math. You're going to go over to PRB, and you find the NCR. But make sure you hit the 8 first. Go 8, then math. Move your arrows over to PRB. Find the NCR button. And then once you hit the NCR button, hit 6, and you should get the number 28, I believe. Am I doing okay? Let's see what the statistics book has to say about combinations a little bit. So this we can clarify it a little bit. Combinations. Suppose Q and R are positive integers. Imagine the set of Q items taken R at a time in no particular order. The possible number of combinations in this situation is symbolized QCR, so that's like our NCR, and it could be calculated from this. How many permutations are there if you have 10 people taking 5 at a time in a specific order? Okay, so if the specific order means something, that's what we need to do. Almost done. How many ways can you select 5 volunteers from your class of 30? How many different ways can you select? Well, select and choose are going to be the same thing. 5 volunteers from your class of 30. So you have 30. Being that we're not naming the volunteers like specific things like president, vice president, things like that, we're just going to say, hey, I need 5 of you to volunteer. No one raised their hand, said, all right, I'll pick 5 of you. I'm going to use some random number generator in order to generate it. How many different ways could this take place?
142,506.
142,506. So if we had someone that came to the door every day, and we had kept us all the same, and I said, okay, I need 5 of you to go do this, and I'll be blah, blah, blah. Here's these 5. Those 5 go out there, 142,506 different ways we can have you leave the classroom to go and volunteer someplace. Okay? So choose and select, go with combination, arrange, and ways you can vote if you are naming specific people, go with permutation.
Mr. Stirrup, if you were to pick 5 people every day, it would take 309 years to do that.
Nice.
Yeah.
Based on how many days we have class? What'd you divide?
Just divided by 365.
Oh.
You did that every day, it's
Crazy. So big numbers, huh? All right. So let's try these examples real quick, and then I can give you the opportunity to. So 5C3, 9P2, ACA, and AP1. Obviously, the 5C3 and the 9P2 can be done with the calculator. The ACA and the AP1, we have to go with the definition a little bit. So 5 choose 3. 10? What do we get? Does everyone get the number 10 on a calculator? 9P2? 72. And then it says, how about ACA? So ACA should go along with this I get 9 factorial over r factorial, n minus r factorial. So n factorial is a factorial. I don't know what that really means. Over this. And then n minus r, a minus a would be 0 factorial. And what did I say 0 factorial is equal to? 1. So 0 factorial is equal to 1. That should give us an answer of 1. So a factorial over a factorial has got to be equal to 1. And then AP1 factorial. Let's just go to the next slide. AP1. So it's going to be a factorial over a minus 1 factorial. And you just get a. How do I get a from here by definition? How do I get a for an answer? That's absolutely right. How do I get a? The answer truly is A. A little critical thinking. How? I'm not going to knock out the exclamation points only. So if I had 5 factorial, so let's say I had this. If I had 5p4, that'd be 5 factorial over 5 minus 1. 5 minus 4, excuse me. So if I were to take a factorial, that's the same thing as a times something factorial over a minus 1 factorial. What is going to go right here? And how do you know? Huh? Why? You're absolutely right, but why? Why is this a minus 1 by definition? What's the definition of factorial? There you go. You're multiplying down the road. So if you had 5 factorial, that's the same thing as 5 times 4 factorial. If you had 100 factorial, that's the same thing as 100 times 99 factorial. If you had 30 factorial, that's the same thing as 30 times 29 factorial. So that's why if I do this, this is going to cancel with that, leaving me just with an A for an answer. Okay? So, our range goes with what? A range goes with what? Permutation. If I have named first, second, and third place, or president, vice president, treasurer, what does that go with? Permutation. If I ask you how many different ways I can choose 6 books, or select 5 volunteers, that goes along with combination. So permutation, God bless you. The order is important. Combination, we're not so worried about it. And that's why the combination locks out there are actually permutation locks, because if your combination to your locker that they gave you that's on your schedule or whatever, matches up to a certain locker, you should be able to put those 3 number sequences in any order if they truly were a combination lock and not a permutation lock. Okay? I want to give you guys the opportunity to work on that worksheet. It looks like it's a front and a back side, not too hard. And again, we'll be checking that off tomorrow. I think with the rate we're going, I think we'll do a quiz on Friday this week. Quiz on Friday this week, so we'll have Monday through Thursday lecture, and we'll have a quiz on Fridays. Does that sound all right? Today, I don't have any meetings scheduled, so right after this class, I'll be over my office at the north end of Stutler Bowl. If you need to make up your test, I'd say give yourself at least 45 minutes. Or if you need to finish up that quiz that you hadn't finished up, give yourself however much time. Sound like a deal? All good? Caesar, life good? What's going on in social network?
just as Johnny met